to section 6.2, and 6.2 is multiplying fractions. And once again, kind of like we talked about yesterday, these aren't all necessarily numerical fractions. We're going to be dealing with mostly algebraic fractions. We'll have some numerical fractions, but for the most part, we'll have several variables included in this. Like 6th grade, whenever you guys first learned how to multiply fractions. So, if we want to multiply fractions, whether we're dealing with 2 fractions or 3 fractions or 10 fractions, regardless of how many fractions you have, okay? So to multiply fractions, you're going to multiply the numerators and multiply the denominators. And then, of course, we're always going to want to simplify. And something that you guys would probably do anyway without me even telling you, you can either multiply the numerators, multiply the denominators, do that first and then simplify. Or what seems to be the easier path most of the time is canceling out common factors at the beginning. So whenever you're canceling out common factors, you call it cross-reducing. So you can either cancel out factors from one fraction or from one fraction to another. Okay, so let's look at an example. Your directions will say multiply. And as always, we want to express in simplest form. One thing I do want you guys to note today is that your directions don't say anything about restrictions, because I know that was probably the most fun part of your homework last night, right? Finding all those restrictions. Your expressions today, you don't have to state the restrictions. Now, just because we're not stating restrictions doesn't mean they don't have restrictions. It just means they're not asking you to state them, okay? If you ever have a variable in the denominator of a fraction, you're going to have some restrictions. You're going to have a case where it could possibly be an undefined answer. Okay, so like I said, there will be restrictions in the fractions today, but you don't have to state what they are. Keep in mind there will be restrictions. There's some things that your variable can't be, but you will not be responsible for stating what they are today. Okay? So, number 1, let's look at -3/8 times 16/21 times 14/6. Okay, so this may be new, multiplying more than one fraction. So let's talk about this real quick, because what you could do is you can multiply all your numerators. 3 times 16 times 14, put that in the numerator. And you can multiply your denominators. 8 times 21 times 6, right? 6. And you'd have a really big number in the numerator, really big number in the denominator, and then you'd have to simplify that, which sounds like a lot of fun and all. But if we don't want to deal with those really big numbers, we can cross-reduce, okay? So if I'm just looking at 2 fractions, I could cross-reduce with the first 2 fractions. Or if I look at the last 2 fractions, I could cross-reduce there too. But something that's new, if the first and the third fraction have something that you can cross-reduce, you can do that too. At any time, because what this really ends up being is a big numerator, a big line across. It's just a bunch of numbers being multiplied in the numerator and a bunch of numbers being multiplied in the denominator. So anything in the numerator can cancel out with anything in the denominator. It doesn't matter what order it comes in, as long as it's all multiplication. Okay, does that make sense? Okay, well, let's look at this. Looking at anything in the numerator and anything in the denominator, what are some things that cancel out? Tara?
3 and 6.
Okay, the 3 and the 6. The 3 turns into a 1, the 6 turns into a 2. What else? Eric?
8 and 16.
Okay, the 8 turns into a 1, the 16 turns into a 2. Anything else? Sarah?
21 and 14.
The 21 and 14, I can divide out as 7. Anything else? Dylan?
2 and 2.
Okay, I've got some 2s, and it really doesn't matter if you want to cancel out these 2s here or these ones here. It does not matter. You'll end up with the same thing either way. Now, since these 2 are just right on top of one another. I'm going to leave it like that. Anything else cancel out? Nope. So we're going to multiply everything that's left in the numerator, which ends up being 1 times 2 times 1, which is just 2, over 1 times 3 times 1, which just gives you 3. Is that my answer? No. What am I missing? A negative sign. So it's negative 2/3. Okay, so you will have a few examples like this today where it's just numbers and you'll either have 2 or 3 or more fractions to multiply. Most of them, as I mentioned, are going to be algebraic fractions, so they're going to be variables included. So let's try 12y over z cubed times z over 15. You do this the exact same way, except now we have some variables that we have to worry about. So we could multiply the numerators, multiply the denominators, and then reduce, or we could cross-reduce first. What can I cancel out here? There's a z that cancels out, right? So that z cubed turns into a z squared. What else? Eric?
Can you simplify 12 and 15?
You can. What do they have in common?
3.
A 3. So the 15 turns into a 5. The 12 turns into a 4. Anything else? Nope. So multiply everything left in your numerator. So 4 times y, and everything in your denominator. Z squared times 5 gives you 5z squared. Once again, there are restrictions here, right? Because if z is 0, the whole denominator is 0. Keep that in mind, but you don't have to actually state it. Okay? Questions on numbers 1 or 2? Okay, now we're going to have to remember some of these awesome, incredible, fun, lovely exponent rules that we talked about last semester. Let's try 2 over y. We're going to cube that whole thing. Cube that whole thing. What does this mean? James?
2 over y times 2 over y times 2 over y.
2 over y times 2 over y times 2 over y. We could actually write that out if we wanted to. But, I mean, think if it's something bigger than a cube. What if it's like a fifth? That'd be a lot of writing, right? What it means in the end is this is actually 2 cubed over y cubed, right? Okay, so we have that rule that we can use. And then we just need to evaluate. What is 2 cubed? 8. So we have 8 over y cubed, okay? Let's try another one of those. What about negative, and then in parentheses, 6n over 7m cubed, and we're going to square that whole thing. Okay, before we start trying to simplify this one, is my answer going to be positive or negative? I hear both. I hear both. Those of you that are saying positive, are you saying positive because if you square a negative, it's a positive answer? Yes? Right? And that's true. Are you squaring a negative in this problem? No, right? That negative sign is not included in those parentheses. So we are not squaring that negative sign. So what kind of answer will I have? A negative answer. And then everything inside the parentheses gets squared. So I have 6 squared and n squared. I have 7 squared and m cubed squared. Okay, and then if we go through and simplify, 6 squared gives me 36. The n squared stays the same. 7 squared gives me 49. M cubed squared, what do I do with those exponents? Multiply. Very good. And can I reduce that at all? Nope. 36 and 49 have no common factors. And then it's n's and m's. Okay, any questions so far? Okay, now we're going to combine what we did in examples 1 and 2 with what we did in 3 and 4. And it's going to be so much fun. You guys are going to really have to contain your excitement on these ones because you guys are just getting way out of control right now. Okay? Number 5. Okay, let's try 4y over z, and we're going to cube that whole thing. So in parentheses, 4y over z, cube the whole thing. We're going to multiply that by 3z over 8y. I know you guys, and I know me, the first thing I want to do is cross reduce. Can I cross reduce? What do we think? Can I cross reduce? Let me rephrase. Can I cross reduce first? No, because I've got those parentheses and I've got that cube. So I've got to take care of that exponent before I can cross reduce. So the first thing I have to do is take 4 cubed, y cubed, and z cubed, and then multiply it by the 3z over 8y. Once my parentheses are gone, then I can go ahead and cross reduce. 4 cubed gives me 64, so if we simplify that, and then we can look back to cross reduce. Looking at my two fractions, what are some things they have in common here? An 8. We can divide out an 8. So the 64 turns into an 8. What else? A z. So that z cubed turns into a z squared. What else? A y. So that y cubed turns into a y squared. Anything else? Nope, I think that's all. So make sure you multiply everything that's left over in your numerator, because I have an 8 times a y squared times a 3, and in the denominator, I just have a z squared. So my final answer would be what? 24. Yeah, there we go. 24 y squared over z squared. Okay, any questions so far? I know, right? I've been trying to tell you guys this the whole time. Okay, I'm going to give you number 6 to try on your own. It's very similar to number 5, and then we'll move on to like the super fun ones. You guys, I'm serious. You guys are just going to lose your mind. Okay, number 6, negative y over 2z. We're going to square that whole thing times negative 6z over y.